right, so if we have a percent of change that is positive, so a positive percent of change, it's called a percent of increase. Okay, so positive increase. A positive percent of change will be called a percent of increase. So what if we have a negative percent of change? What do you think that's going to be called?
A decrease.
A percent of decrease. Okay, so a negative percent of change is going to be a percent of decrease. Yeah. We all caught up? Got it all copied? Almost done? Alright, so let's look at some examples now. Alright, so we want to find the percent of change in cost of gas. That was quick. So we're finding the percent of change in the cost of gas from 1970 to 2008. So this is the problem. Okay. So in 1970, the gas cost $1.30. And then in 2008, the gas cost $3.95. Alright, so if you remember, we needed to find the amount of change over the original amount, okay? So in order to find the amount of change, it's the final amount minus the original amount. Okay. So what do you think the final amount is? $3.95. Okay. So we went from gas costing $1.30 in 1970 to costing $3.95 in 2008. So my final amount is the cost in 2008. Okay. And then we're subtracting the original amount, which was $1.30. So when I subtract those two numbers, what do we get? 265. Okay. So this is the amount of change. So it changed $2.65 between those 2 years, or that amount of years. Okay. So now we need to find the percent of change. So if you remember, the percent of change, we use this formula right here. We've got final amount minus the original amount, which is what we just found, 265, all over the original amount. Okay. So 265 all over the original amount. So what did we say the original amount was? 130. So I've got 265 over 130. Now I want to just divide those two numbers. So 265 divided by 130 gives me 2.04, right?
Yeah.
It gives me a long decimal, but since we're dealing with money, so this is what I actually get right here. 2.03846, so forth. But since I'm talking about money, cost of gas, I need to round to the nearest hundred, so 2 decimal places, okay? So that means I need to round to right here. So that 8 next to the 3, since it's larger than 5, anything 5 or larger, remember that tells us to bump it up. So I bump that 3 to a 4. If it's 4, 3, 2, or 1, it stays the same, okay? So we're bumping it up to 4, so that means my percent of change is 2.04. But that's not in a percent. That's given to me in a decimal, right? I need to find the actual percent. So does anybody know how to change a decimal into a percent? Faith, do you have your hand raised? Okay, you can move the decimal over 2 spots to the right, or you can simply multiply by 100. Either one, and it gives you the same answer, okay? Because multiplying by 100 means you're moving this decimal over to the hundredth position, okay? So if I multiply 2.04 times 100, I get 204%. So my percent of change is 204%. Ja'Cory. How did I get what? From dividing 2.65 by 1.30, and then you round that up. Okay. So my percent of change between gas in 1970 and 2008 is 204%. Now I want to find out if that was a percent of increase or a percent of decrease. So what do you think? A percent of increase, right? Because from 1970 to 2008, gas got more expensive, right? So that tells me that this is a percent of increase. So you can pretty much tell whether it's an increase or a decrease just by looking at the problem before you even find your percent of change, okay? If you start out with a smaller number and you grow to a larger number, that's going to be an increase. But say that I switch the years here. So say that gas in 1970 cost $3.95, and then gas in 2008 costs $1.30. What would that be? A percent of decrease. Okay. Questions on that problem? All right, let's do another example. So we're going to find the percent of change from 10 yards to 13 yards. So we're going to kind of combine everything in one step now. So our original formula is final amount, I'm just going to say final, minus the original amount, all over what? The original. Okay. So final amount minus original amount, all over the original amount. So somebody tell me what my final amount is. 13. My final distance is 13. And then what's my original distance? 10. So it's all over 10 as well. Okay. So then using my order of operations, I know I have to subtract my top first. So 13 minus 10 gives me 3. So I have 3 over 10. Now I want to divide those and get a decimal. Okay, so 3 divided by 10 is going to give me a decimal of what? 0.3. Oh, sorry, I put my 0.03. 0. Get my white out. .3. Okay. But am I finished? No, because that's a decimal and I need to change it into a percent. So like Faith said, I can either move that decimal over 2 places, which means I would have to add another 0 right there. Or I can say in my calculator 0.3 times 100. Either way, I'm going to get 30%. Okay. So the percent of change between 10 yards and 13 yards is a 30% change. So is that a percent increase or a percent of decrease? Increase. All right, one more example, and then I'll let y'all get started on the homework. Okay, so example number 3, we're going to find the percent of change from 30 inches to 24 inches. So remember, our formula is final minus original. All over original. Good. So what's my final? 24. And then my original is 30. So 24 minus 30, all over 30. So what do I get when I subtract 24 minus 30? Negative 6. So now I have negative 6 divided by 30. What do I get? Negative what? 0.2. Okay. So if I want to change that to a percent, what do I get? Negative 20%. Okay. So what does that negative tell me? A percent of decrease. Okay. Which you can already tell from the problem. 30 inches to 24 inches, right? 30 is larger than 24, so it got smaller. So it's a percent of decrease. Okay. And my percent of change is negative 20%. Please don't forget your percent sign, okay? Because negative 20 is totally different than 20%. If it's asking, which I'm pretty sure your homework does, it asks for you to tell them whether it's a percent of increase or decrease, then yes. Yes, I think it does. Okay. So, your homework today is page 348, numbers 6 through 14 evens. And then number 17, 18, 20, 22, and 26. So it's 10 problems. It shouldn't take you too long. So go ahead and get started. You've got about 10 minutes to work on it before we go to lunch. Oh, about 15 minutes.